Hey everyone. So here in this video, we're going to talk about some example problems for the Unit 2 test. So these are all examples of the problems that you saw on Unit 2 test so that when you go to do the corrections, you have something to refer to if you are in doubt of anything. But you should be watching all of these. Even if you got it right, it might be a good idea to watch it. But for number one, this is my example. This is not the problem that you did, but it's my example. We are asked to identify the vertex of this parabola based on what we see here. Now, this is in vertex form, but you notice that we're missing something. So notice we're missing, normally vertex form says y equals a times x minus h squared plus k. We're missing this last thing that we're adding here. Since there's nothing being added, that is saying plus zero, because it's nothing, there's nothing there. And so we can say that our vertex is 2, 0, because remember we changed the sign on the x value and we keep the sign on the last one. So that's our vertex for number 1. Actually, this is part A, right? For part B, most students did part A correctly, but most students did part B wrong. They just saw the numbers there and they said, okay, the first number is 9 and the second number is -2, so I'm going to put that as my axis of symmetry, sorry, my vertex. No, because we need to make this look like this, okay? Now there's a couple ways of doing it. I'm going to do it the long way so that you can make a connection with the way that I've shown you in the past. But notice this here. What is our A value? Well, our A value is, remember, the A value is the number in front of the x squared. So the A value is 9. B is not present here, right? B is the number that's in front of the x if this is in standard form. B is 0 here. And C is the constant at the end. C is -2. If you wanted to rewrite this, you could say y equals 9x squared plus 0x minus 2. And the reason that works is because 0 times x is 0, so it cancels out and you'd be left with this. So how would I find my vertex given standard form like this? Well, remember, vertex, you got to find your axis of symmetry first. That's -b over 2a. And in our case, b is 0, so we can just put -0 over 2 times 9. Well, that's going to be 0 over 18. And 0 divided by 18 is just 0. 0 divided by anything is 0. So our axis of symmetry is 0. And to find the vertex, we would take that 0 and plug it back in. So that would say 9 times 0 squared plus 0 times 0 minus 2. Well, all of this goes away, and you're just left with -2. And so as a result, your vertex is going to be is going to be 0, -2. Okay, my x value here and my y value there. Now, pay attention to this because you can also see this in vertex form pretty easily. Because there's no b term, we can view this as vertex form. We could say that this is actually 9 times something squared minus 2. So notice we are squaring something. Well, what is it we're squaring? The square and the square. We're just squaring x. So what is it that I'm adding or subtracting to x to make x squared? Well, that would be 0. X minus 0 is just 0. Or sorry, x minus 0 is just x. So we can see that they're the same thing, but then we can see our vertex is 0, -2 there. Okay, so that's for part B. Again, a lot of people got part A right, but not part B. Let's go ahead and take a look at number 2. Number 2 says let y equal, and I'm going to have to zoom out here so we can see the rest of it. Actually, we could probably see most of it there. Let y equal -2 times x minus 7 squared plus 5. And it says to describe the transformation of the parent function y equals x squared. Okay? So remember when we describe the transformation, we always start off with the same thing. We say the parent function of y equals x squared is, the first thing we talk about is a reflection. We know that there's a reflection if the a value is negative. So in this case, there is a reflection. So we'd say is reflected reflected about the x-axis. And of course, if there was no negative there, you wouldn't have to put the reflection at all. You could just ignore that part. Then we talk about our vertical stretch or our vertical shrink. Because the A value has a value that's greater than 1, right? It's a vertical stretch. So we'd say vertically stretched by a factor of 2, because our A value is 2, right? And then we talk about our translation or our shift. So we'd say then and shifted or translated 7 units right and 5 units up. Okay, because we can see the vertex is +7, +5, right? Let me write that down here. Vertex is +7, +5. Now, you didn't necessarily need to write that down for the description. This is the description here. Okay, so you would have gotten 1 point if you talked about the reflection, 1 point for talking about the vertical stretch or the shrink accurately, and then 1 point for the translation or the shift. Okay, part B says to graph the parabola that is represented by y in the coordinate plane. So we're going to create our own coordinate plane here so that we can graph it. And we notice that the vertex is 7, 5, so that's actually pretty far to the right. So I'm going to set up my graph accordingly. Okay. It's pretty far over. Okay. So we have a vertex of 7, 5. So we're going to go right 1, 2, 3, 4, 5, 6, 7. We're going to go up 1, 2, 3, 4, 5 and put our point. So we have our vertex. We know that the parabola opens downward. And then we also have to look at our slope pattern. So remember, our normal slope pattern is 1 over 1, 4 over 2, and 9 over 3. But because the A value is -2, we have to take all those values and multiply them by -2. And remember, when we're multiplying by -2, it's -2 over 1. So we can multiply the fractions correctly. So that would be -2 over 1, -8 over 2, and -18 over 3. So from the vertex, we're going to go down 2 and write 1. From the vertex, we're going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8, and write 2. And then we'll go down 18, which I'm not going to have enough room, so I'm just going to leave it like that. Then I'm going to reflect along on the other side of our axis of symmetry. And then we're going to connect the dots in some sort of smooth manner. Okay. What I found on number 2 was that students did pretty good on graphing the parabola. It was the description that they had a hard time with. For part B, it was worth 3 points. You got a point for plotting the correct vertex. You got a point for the parabola opening downward in this case. If yours opened upwards, then you would get a point for that. And then you got a point for plotting your correct slope pattern. Okay. All right, let's go ahead and take a look at number 3 now. It says, write the function in standard form. Write the function in standard form. So number 3, we have y equals 6 times x minus 3 squared minus 5. And we want to write that in standard form. So the first thing we have to do is we have to deal with our exponents. So to deal with those exponents, that x squared means we're taking the parenthesis and we're multiplying it by itself. So x minus 3 times x minus 3. And now we just have to simplify this. So off to the side, I'm going to do the work for the x minus 3 times x minus 3. Remember, we separate that, so we'd say x times x minus 3 minus 3 times x minus 3. Then we'll distribute, so x times x is x squared. X times -3 is -3x. -3 times x is -3x. And -3 times -3 is +9. Combining like terms there, we would get x squared minus 6x plus 9. And so that is to replace the multiplying here. So we're going to rewrite 6 times x squared minus 6x plus 9 instead of x minus 3 times x minus 3. Then we can distribute the 6. So we end up with 6x squared minus 36x plus 54, and then minus 5. Then we'll combine like terms. So we end up with y equals 6x squared minus 36x, and then 54 minus 5 is 49. Some big numbers there. But that is our standard form for number 3. Okay. Let's take a look at number 4 now. Number 4 says, what is the function in vertex form? What is the function in vertex form? Well, we've got y equals negative 3x squared minus 12x minus 6. So this is going to be dealing with a lot of number sense stuff. Remember, in order to write it in vertex form, you have to find the vertex. Well, in order to find the vertex, we have to find the axis of symmetry. So let's do that first. Let's find the axis of symmetry. Remember, the axis of symmetry is x equals negative b over 2a. So we have to identify those pieces. Remember, a is negative 3, b is negative 12, and c is negative 6. We'll plug those values in here. So negative b, that would be negative parentheses, negative 12, over 2 times a, which is negative 3. And then we simplify that. I saw some students plugging in c on the bottom here. No, we want to plug in a. It's negative b over 2a. So you end up with 12 over negative 6, which is negative 2. So our axis of symmetry is x equals negative 2. That's the first thing. Then we need to find the vertex, so we're going to plug that into our function. We get negative 3, parentheses, negative 2 squared, minus 12 times negative 2, minus 6. And again, order of operations, do the exponents first. So negative 3, we're going to carry everything else down and only focus on the exponent. So what's negative 2 squared? Negative 2 squared is negative 2 times negative 2, which is positive 4. And then we can multiply. So negative 3 times 4 is negative 12. Negative 12 times negative 2 is positive 24, and then minus 6. And then simplifying that, negative 12 plus 24 is positive 12, minus 6 is 6. So then we would say that our vertex is the x and the y value. So that would be negative 2 comma 6. That's our vertex. Now we want to write it in vertex form. So we're just going to plug those values into our vertex form. Our vertex form is y equals, remember our a value is the same as the a value from the original problem. A is negative 3. And then parentheses x something squared plus something. Well, our x value here is negative 2, so we're going to change that to say positive 2, because remember we always change that sign. And then that's positive 6 for the y value, and we keep that sign. That's just the rule. And so this is our vertex form for the given standard form, okay? All right, a lot of issues that I saw, some students knew how to find the axis of symmetry just fine. They plugged in the x value and they had a very hard time finding the y value. So that is just number sense and knowing your order of operations, knowing positive and negative numbers, how to add them, subtract them, multiply them, and all that, okay? Those were some struggles, but if you got to that point, you were pretty good about writing the vertex form, okay? Let's look at number 5. Number 5 is a multi-parter. It gives you a function. It says y equals negative 1/2 x squared minus 5x minus 8. And part A says find the axis of symmetry. So we just did that in number 4. It's going to be the same thing. X equals negative b over 2a. So our b value is negative 5. So this will say negative 5 over 2 times a. In this case, a is negative 1/2. That's interesting. And then we need to simplify that. Well, negative 5 is just 5. This one might be a little bit tricky, but it shouldn't be too bad. First of all, a positive times a negative is a negative. Secondly, 2 times 1/2 is the same as saying 2 of 1/2. So if you have 2 halves, what does that make? Or another way to say that is, what's 1/2 of 2? Well, that is 1, okay? If you can't see it that way, then you would say, okay, what's 2 times negative 1/2? Well, remember to multiply fractions, you got to have fractions first, so we put that over 1. And then we multiply straight across. 2 times negative 1 is negative 2. 1 times 2 is 2, and then that simplifies to -1, and that's why we got -1 here. Now, 5 over -1 is -5. If you just left it there and said the answer is -5, you missed out on a point, because remember, an axis of symmetry must be written as an equation. It's x equals -5. That is our answer for our axis of symmetry. So maybe you made a mistake based on that. All right, for B says find the vertex. Well, again, we did that in number 4 here. Once you have your axis of symmetry, you just plug that into the equation to find your y value. So in my case, I'm going to plug in -5 here. Now, mine is a lot more complicated than yours because yours should all have whole numbers as a final outcome. Mine may not. So I plugged in -5 to x, -5 to x there as well, and then now I'm going to simplify. So remember, carry everything down except dealing with the exponents. And so -5 squared, -5 times -5 is +25. And then we'll simplify this. Well, -1/2 times 25, you guys have a calculator. So this is going to be -12.5. And then -5 times -5 is 25. And then -8. And then -12.5 plus 25 is 12.5. Minus 8 would be 4.5. And so our vertex is going to be -5, comma 4.5. That is our answer for the vertex. Okay. Now in C, it asks us to graph the parabola. I'm going to go ahead and do that over here. Graph the parabola. And we should be okay with this. This is really going to be disgusting, but that's okay. Because of my decimals, I'm going to have a little bit more of a tricky time doing that. But again, yours should not be so difficult. And I can't remember when I was writing these problems whether I intended for me to make have such difficult problems for myself or if it was just an accident. But regardless, we're going to go back 5, 1, 2, 3, 4, 5, and we're going to go up 1, 2, 3, 4 and a half. So we're going to be actually right there for our vertex. Okay. Now we need to create our slope pattern. Remember, our slope pattern is normally 1 over 1, 4 over 2, and 9 over 3. But here we need to multiply it by a half. Now, when I multiply it by the half, because the a value is -1/2, I need to make sure that I'm multiplying the top only by 1/2 or -1/2. So I'm going to put that as a decimal. I'm going to multiply it by -0.5. That's the same thing as -1/2. Okay. Again, put those over 1 and then multiply across. 1 times -0.5 is -0.5 and then over 1. 4 times -0.5 is -2 and then 2 times 1 is 2. 9 times -0.5 is -4.5 and that would be over 3. So from here we're going to graph. So here we're going to go down 1/2 and over 1. So now we're on a nice clean number there. From the vertex, we're going to go down 2. So halfway is kind of weird, but if I end up on a half, that's 1, and then 2 is here over 2. And then we're going to go down 4.5. Well, that's down a half, so I'm going to go down 4 more. 1, 2, 3, 4, and over 1, 2, 3. Now notice I got a lot more room on my graph, so I can actually keep going here. The next part of my slope pattern will be 16 over 4. So when I multiply that by -0.5 over 1, I get -8 over 4. So -8 would be 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. And we'll do one more just for the heck of it. That's going to be 25 over 5. Multiply that by -0.5 over 1, which is -12.5 over 5. So down 12.5. Again, that's a half here. So we're going to go down 12 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, 2, 3, 4, 5. And then we'll reflect that all on the other side here. And we should be able to graph it pretty accurately. I'm running out of room, so I'm just going to leave it like that. Okay. And then on this side, we have that. Okay, so that is part C. Part D, it's asking for us to identify our x-intercepts, Now, our x-intercepts are found in the graph. We're going to learn how to find x-intercepts without graphing later on. But for now, we should be able to see our x-intercepts pretty quickly. Remember, our x-intercepts are where the graph crosses the x-axis. So what are those coordinates? Not what are the values, what are the coordinates? Well, this one is back 2, 4, 6, 8. Is that right? 2, 4, 6, 8. And this one's back 2. So we don't want to just say -8 and -2. They're coordinates. So we're going to write -8, comma 0, right? That's that coordinate, back 8, up 0. And -2, comma 0. Those are my x-intercepts. Okay? Now E is asking for the y-intercepts. Okay? The y-intercept. Now, the y-intercept, if you graphed it right, you can see the y-intercept in the graph. But if you didn't graph it right, you should still be able to see the y-intercept in the equation. So remember, the y-intercept is the c value of your equation, of your standard form equation. We can find the y-intercept without even looking at the graph, and that's important. So the y-intercept here is going to be 0, -8. You should be able to identify that, 0, -8. You should be able to identify that without graphing if it's in, excuse me, if it's in standard form. But you can then use it to check to see if your graph makes sense. So if I go over to my graph, the y-intercept can be seen right here. Well, let's see if I graphed it right. If I go down 1, 2, 3, 4, 5, 6, 7, 8, you can see that I went down 8. My y-intercept is 0, -8. Okay, so that wraps up number 5. Let's go ahead and take a look at our last problem here, number 6. And I got a graph here that I'm going to show you in a second. But let me go ahead and write these things down that we're doing. For part A, we're asking for the domain. For part B, we're asking for the range. For part C, we are asking for the interval of decrease. And then for part D, we're asking for the interval of increase. And then for part E, we're looking for the average slope over the interval -3 to 2. So I'm just going to write these down as side notes so that when I go to look at the graph, that's not all in the way, because here's the graph right here. Okay, so we have this big graph. Well, remember, domain is the set of x values. So what we want to do is we want to look all the way to the left and see how far this graph goes. And we can see that this graph stops at -5. Okay? And we go all the way to the right and we see that this graph stops at +7. Now, domain is the set of x values. And the question is, does the graph actually touch x equals -5? Yes, it does. So we're going to put less than or equal to. Does the graph actually touch when x equals 7? No, it doesn't, because it's an open circle, so we're just going to put less than 7. So that is our domain in inequality form. Inequality form. Okay? And I'll go ahead and do these on all of them. The interval form would be -5 with a bracket and 7 with a parenthesis. Okay? Now going back to the question says, what is the domain of the function? Write your answer in inequality form. So our inequality form would be this one. So if you put it in a different form, or if you had, an equal sign when you shouldn't have had it, or vice versa, you lost out on some points there, okay? Or half a point, I believe. The range is the set of y values. So what's the lowest point? What's the highest point? Well, the lowest point that this graph gets is -9. And the highest that this graph gets is 7. Not this 7, not this x value 7, but this y value of 7. And this is range, so we're looking at the y values. We can see that it doesn't actually go down to -9. It gets really close to it, so we're just going to put less than. And then when we go up to 7, it does touch 7, so we're going to put less than or equal to. Again, interval form would be a parenthesis -9 and a bracket for 7. because we're not counting -9. The less than symbol implies a parenthesis, and the equal symbol implies a bracket. Again, in part B, it asked for your answer in inequality form. Part B, inequality form. So our answer is going to be this one here. Okay. For part C, it's asking for the interval of decrease. So where is this graph decreasing? We can see that this graph is going downhill in actually two different places. From here to here, it's going downhill. And then from up here to down there, it's going downhill. So where does it start going downhill in the first one? It starts going downhill at -5, and it stops going downhill at -3. So we're going to put x less than or equal to here, less than or equal to there, because the function exists at those points. And we also have another answer for this. We could say and from 3 less than or equal to x all the way over to 7, but we're not counting 7 because that's not part of the graph. In interval form, that would look like -5 brackets, comma -3 brackets, and 3 brackets, 7 parentheses. Okay, so we go back to our question and we realize that for part C it said write your answer in interval form. So our interval form would be this one. So if you put it in inequality form, again, you lost some points there. For the interval of increase, in this case, we can only see one place where the function's increasing, and that is from -3 all the way up to, or all the way to the right 3. That's inequality form. Interval form would be -3 with a bracket and 3 with a bracket. And again, it said interval form, so we're going to write it like this. Okay. And the last problem says, what is the average slope from -3 to 2, or x equals -3 to x equals 2? So the first thing we have to do is identify these coordinates. Well, if I go back to -3, I can see that my y value is -5. So my first coordinate is going to be -3, comma -5. My second coordinate is when x is 2. So we're going to go right 2 and up to 6. So my second coordinate is 2, comma 6. And we'll write the slope formula from that. So remember, slope is equal to y2 minus y1 over x2 minus x1. So y2 is 6 minus y1 is -5 over x2, which is 2, minus x1, which is -3. Simplifying that, 6 minus -5 is 11, 6 plus 5. And then 2 minus -3 is 2 plus 3, which is 5. And we can't simplify that, so we would just say 11 over 5. We can check our work by saying if I start at -3, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over 1, 2, 3, 4, 5 to get the x value of 2. All right, so that wraps up all the different types of problems that you saw on your Unit 2 test. Now you go back and do corrections on the problems that you missed any points on, and then get that turned in. Remember, to be able to do the recovery, you got to get your corrections done. You have to get your contract signed, and you got to make sure everything for Unit 2 is done. I hope this helped you out, and I will talk to you later.